Let me review one sample t-test today. We had one population, so we took one sample. Do you remember what was a population, what was a sample? You know, the population is the target group, what we are interested in, but it is huge. Yeah, we cannot take care of it. So in statistics, it's always we just take part of them. That will be the sample, right? And in the t-test, we want to know what is the mu. You know, actually the mu is the population mean. So in the one sample t-test, we want to know what is the population mean, because we don't know anything. It's not only the population mean, but we don't know anything in the population, but now the target is the population mean. So in step number 1, the null hypothesis, initially we set up the unknown population mean is a value, the mu 0. Yeah, please remind the STAT 1. Yeah, as some of you took the STAT 1 a semester before, a year before, or as more than 2 years ago, right? So please remind the STAT 1, the one sample t-test. So in step number 1, we stated the HO, it is the null hypothesis. And definitely we had another hypothesis. Do you remember that? It's HA. It's an alternative hypothesis, right? So the other one is HA. HA has 3 statements. The unknown population mean, mu, is not equal to the value. We call this one is a two-sided. It might be bigger. It might be less. So we can choose as one of the inequalities in alternative hypotheses. And we said the first one is a two-sided. It's a two-sided. Two-tailed, two-sided, it's the same thing. Let me say it's a two-tailed. And this two is a one-tailed. The greater this way is the right tail. And less than, that way, the left tail. So do you remember? Right? So in step number 1, we stated the hypothesis. It's 2 kinds of hypotheses. It's HO and HA. Always in the null, there is the not equal sign. But alternative statement has the 3 ways. It's not equal to, greater than, less than. It depends on the claim. Okay? So we chose is one of them. But the problem was we don't know anything. We don't know anything in the population. So always we played with the sample. So now we can take the sample mean. Because the sample mean is the X bar is a sample mean. And it is the point estimate for the unknown population mean. We can take one-to-one. When I want to know what is the population mean, then we can take the sample mean. If I want to know the population standard deviation in the population, right, then we can take the sample standard deviation. Whatever in the population, we can take whatever from the sample, right? So we can make the pair as a one-to-one, right? So in this case, we can take the sample mean. So now, in one sample t-test, we did the test. So the second step, we take the test statistic. Can you remember that? It was the t-score. The second step to take the test statistic, which will be the t-score. Basically, we can take the difference. Basically, we can take the difference between the point estimate, x bar, for the population mean. That is what we want to know. Minus the initial value. You know, at the beginning, we set up the initial value, the mu0. So basically, we can take the difference. We can take the difference between the two values. How do you think? If the difference is big enough, it's apart, right? It's a quite so big difference, so big distance between the estimate and initial setting value. What does that mean? They are different, right? Now I can say they are unknown population mean. I mean the mu, I mean here is a mu and the mu0. They are different. So the procedures, the t-test said if they are different, they are apart so much, then we have to say, they are not same. So what was the decision? Reject the null statement. Can you remember the procedures, right? It's a step by step, right? But the other way, if they are close enough, I mean the difference between the x bar and the mu0 is so close. It's almost the same. Then what does that mean? Even the unknown population mean, right? And the value is close enough. They are almost the same. It's not exactly the same, but they are close enough, right? It's quite similar. What will be the decision? Not reject the null statement, because we have to say they are same. Why? Because even though the x bar is not the mu, but the x bar is kind of the representative of the mu, right? It's a point estimate of the mu. So practically, we compare the x bar and mu0, and we can interpret it's between the, yes. We can compare the unknown population mean and the initial setting value. So the test statistic is not only the difference between the two values, but also we have to do division s over square root of n. Okay. Always the test statistic is kind of the ratio. It always has the form, the difference, basically, it's divided by the standard error. Can you remember the standard error? So the denominator is another ratio. Oops. Yeah, I'm sorry. Yeah, the denominator is another ratio that has the name, the standard error. So take the test statistic is the second step. And the third step, we can take the p-value, right? And also, we can make the decision. Just a second. It must be here. Yep, it's a decision. And finally, it's a conclusion. Conclusion is it's kind of the interpretation. Just a second, how can I do? Yes. So it is the one sample t-test. It's always, we have 5 steps. So it's after this, we are going to review the 2 sample t-test. It's actually, it will be the pooled t-test, right? That was almost the last topic in STAT1. So today we review one sample t-test, and next time is maybe next week. We are going to review the second one, the pooled t-test, and ANOVA will be the first main topic in STAT2 in this course. So everything is related. Okay. So please remind what was the one sample t-test. Every single test procedure, we can apply the 5 steps. Always state the hypothesis in step number 1. Always we take the test statistic. It's probably in another procedure, we are going to take another test statistic. And p-value, make the decision, and the conclusion. It's every single procedure. It's any kind of statistical procedure. It's always we apply the 5 steps.